Dun, 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 dun. This is like I found this question on an old AP test. I thought it was groovy enough to put like on every test. So there it is, right? So MNOP, Mn starts at 400 pascals and 8 cubic meters. So where's that? That's here. Okay, so 408 and 400, right? And it heats and 480 kelvins. Okay, heats isochorically at a constant volume. So it's going to stay at this volume, right? To 1100 pascals, which is like here. Okay, so it's going to go up to here. Okay, so this is M, N, right? And then it, let's see, then there's NO as an isobaric expansion to 10. Okay, so isobaric means same pressure, right? So this guy does this. Hope you appreciate how straight that line was. This is MNO. OP is an isochoric cooling, so that goes straight down to back to 400 pascals. Okay, and then PM is an isobaric compression back to 8 cubic meters. M and OP. All right. Let's see. So what does it say? Draw this cycle on the graph above. Okay, we did that. Calculate the work done, the moles, and the temperature of the vertices. Okay, so let's do the work done. The work is area is height times width. And this is easy. It's a rectangle, right? So the height of this is 200, 400, 600, 700, right? So 400 to 1100 is 700 pascals high. The width of it is only 2 cubic meters. So that is 1400 joules. It's positive because it's clockwise, because it does work on the world at a higher pressure than the world does work on it. Okay? Okay, so calculate the work done. Did that. The moles. Oh, okay, let's see. The moles are going to be, let's see. N is PV over RT, is that right? Okay. So we know that that's 480 kelvins, right? So at M, we know it's 400 pascals, 8 cubic meters. It says it right here, okay? Okay, and then R is still 8.31, and T is 480. Okay, I can do this. 400 times 8. You're asking a lot of me, by the way. Divided by 8.31, divided by 480. And I get that the number of moles is 0.80222246 or something like that, moles. Okay. Then it says find the temperature of the vertices. Okay, so let's find this temperature here. Okay, so N. And, maybe the easiest way to do this is just go ahead and use, so the temperature at N is go ahead and use the ideal gas law, right? So it's going to be PV over NR, right? So at N, the pressure is 1100. The volume's still 8. N is 0.8022. And R is still 8.31. Okay? So 1100 times 8 divided by N, which I just got, right? Divided by 8.31. Now, when I do that, I get this strangely even number, 1320 kelvins. And whenever that happens, you should ask yourself, is there a better way to do this? And of course, the better way to do this is that it's 480 times the ratio of 1100 over, what is this guy, 400. Okay? Because notice that the pressure rose from 400 to 1100, right? So therefore, the temperature must also rise by the same factor. So let's try that. 480 times 1100 divided by 400. And by golly, that equals 1320 kelvins, right? Okay. And then we can find the temperature at O. That's going to be, let's look at that. That's 1100. But our volume is now 10 divided by 0.8022 times 8.31. So 1100 times 10 divided by the number of moles divided by 8.31. And when I do that, I get 1650. Right? And of course you shouldn't, there's got to be a better way to do that, right? So I bet that it's 1320 times 10/8. And the reason is that we go from 10 to 8, right? So the temperature's got to rise by the same amount. So 1320 times 10 divided by 8. Hey, that's 1650. All right, so let's see. Temperature TP. Let's find TP. Sorry, I'm not very mature. Okay. So this is same thing, right? It's PV over NR, right? So P is 400 times 10 divided by 0.8022 times 8.31. So 400 times 10 divided by that divided by 8.31. Hey, that's 600. That's a strangely even number. I'm using this number unrounded, right? So how else could we get it, right? It also could be, what was that temperature? 1650, right? And then notice that the pressure dropped from 1100 to 400, right? So it's going to be 400 over 1100. So 1650 times 400 divided by 1100 is 600. All right. Wow. That's so much stuff and talking and writing. I'm surprised you watched this all the way to the end. I hope I'm recording.